In this lesson we're going to solve some basic trig equations, and the best way to go about doing that really is just to show you some different types of equations and give you some kind of tips to do. So the first one is a first degree, very basic first degree equation. I have a single trig function in it, nothing squared, and we solve this very much like a first degree regular equation. So the first thing we do is isolate the trig function, meaning I want to get the sine of x by itself. I do that by first adding any constants and then dividing by the coefficient. So if I do that, I get 2 sine of x is equal to 1, and now I have sine of x is equal to 1/2. So this is solved by just using the inverse functions like we talked about in the previous lesson. Sine of x is 1/2. That means the inverse sine, or x, is going to be equal to the inverse sine of 1/2. And if we think about it, if I were to solve for that, because the sine curve is periodic, I could have an infinite number of solutions. So we want to restrict our domain in these problems. We want to restrict x to, let's just say, let's go from 0 to 2 pi. So I'm only looking for one trip around the unit circle. Okay, the square bracket means it includes 0, the 2 pi means it does not include 2 pi. So now if I think about how many solutions that is, I want to know how many solutions, where is sine of x positive, first of all. And it's going to be positive in quadrant 1 and 2. So I'm looking for a first and second quadrant answer. And then if you think about what angle, the sine of what angle is equal to 1/2, that's one of our special ratios. It's 30 degrees. So I know it's 30 degrees. The second quadrant angle is 150. So in terms of radians, it's pi over 6 and 5 pi over 6. You should answer your questions in radians. You can start in degrees, but I also need a radian answer. All right, my second example has a tangent squared, and again we're going to solve this from 0 to 2 pi, which is what we're going to assume every question in here we're going to solve from 0 to 2 pi. That's going to be our domain for all of them. So tangent squared of x. Again, I can solve this by isolating the trig function, even though it's squared. Whoops, tangent squared of x is equal to 3. I'm going to take the square root of both sides, and remember when you do that, this is like solving an incomplete quadratic. You need to use positive and negative because you'll get two answers. So x is the inverse tangent of positive and negative radical 3. That tells me I'm going to have 4 answers because I have my positive values and my negative values, and I have 2 answers for each one of those. So I'm going to go all the way around the unit circle and have 4 different answers. The angle where the tangent is radical 3, you can do your special triangles, but it ends up being 60 degrees because tangent of 30 is radical 3 over 3. So 60 degrees all the way around the unit circle would be 60 and 120 and 240 and 300. So that's pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Those are your answers. We're going to look at quadratic equations next. These are our second degree equations with more than one term, so I can't just isolate the variable or isolate the function and take the square root of both sides. This we treat just like we used to do a trinomial. What we want to do is use a let statement. Use a let statement to make my expression a little bit simpler. Let's let y be equal to the cosine of x, and then rewrite our expression. This now becomes 2y squared minus 7y plus 3 is equal to 0. You do this when you have everything in terms of one type of trig function. And this is factorable. We can break it up into 2 parts here. The 2y squared splits up into a 2y and a y, and then I need to place my 1 and a 3 such that when I do inners and outers, I'm going to get a 7. The last term's positive, The middle term's negative, so I know they're both going to be negative. And if I put a 3 back here and the 1 up there, that means I have a negative 1y and a negative 6y, and that gets me my negative 7. All right, make your t. 2y minus 1 is equal to 0. Y minus 3 is equal to 0. This ends up being y is equal to 1/2, and y is equal to 3. Now what you have to remember is to substitute back in. The cosine needs to replace the y. And I have the cosine of x is equal to 1/2, and the cosine of x is equal to 3. I'm crossing this one off. Think to yourself why I'm doing that. And I need my answer to be the inverse cosine of 1/2. And we are going from 0 to 2 pi, so I need my positive quadrants, which is quadrant 1 and quadrant 4. So the ratio, the angle that creates a ratio of 1/2 for cosine is 60 degrees. So there's my first quadrant angle, and there's my fourth quadrant angle. So in radians, it's pi over 3, and it's 5 pi over 3. If you need to, you can use your calculator to get this, but you should get, this is one of our special ratios, so you should get one of your special angles. The last one we'll do for our notes is this goofy looking one here. I have a secant of x multiplied by 2 cosine of x minus radical 2. Since this thing is already equal to 0, it's already factored. You're going to break up the two factors because this is essentially kind of a second degree because I have one function and I would multiply it by another function. It's already factored. So you'll set each factor equal to 0 and solve each one individually. Well, secant is the reciprocal of cosine, so 1 over the cosine of x is equal to 0. And then on the other side, I have 2 cosine of x is equal to radical 2, so cosine of x is equal to radical 2 over 2. So the reciprocal of cosine is equal to 0. If you think of the graph of the secant function, you know it never crosses 0. So this one has no solution. If you were to cross multiply, the cosine would be multiplied by the 0, which would not be cool. And you would have 0 is equal to 1, so it doesn't work. There is no solution for that side. But for the other side, the angle that creates a ratio of radical 2 over 2 in a right triangle is 45 degrees. So there's my first quadrant angle. I need the other positive one, which would be in the fourth quadrant, so that's 315. And then in terms of radians, it's going to be pi over 4 and 7 pi over 4. So we're going to practice more of these examples in class. The more examples you do, the better you get at these. And we're also going to use our calculators in class to solve these graphically and check our work.